What happened was I was in Australia, UNSW 2009. I'm part of the Society of Mining Professors all over the world, and I went into their center in Sydney, and I was so amazed by what they have in the sense of this 10-meter diameter cylinder. It's got 4.5-meter high walls, it's got 5 projectors, it's immersive technology. You put on 3D glasses and you're right in the mine, you know. And the thing that struck me, they put us through a fall of ground exercise. My goodness, you've got no idea how much the people around me got affected by the fact that they experienced the fall of ground and no one got hurt. Because the surround sound around it, the whole issue of the effect of the visuals and so forth. I mean, everybody, when they walked out of there, they said, no, my goodness, this is something special. You know? So I came back to South Africa after that visit. And the University of Pretoria Mining School, we've got a very, very active mining advisory board, and we also have a very strong alumni. But at the first mining advisory board, Chris Griffiths then was the CEO of Kumba. So he sits on my advisory board, and I do this nice presentation, everything, and I say to the guys, yes, I saw something spectacular. What is it? I show them a nice video of this facility, and I said to them, we must have something like this. And then I made the comment, I said, you know what, but it's so damn expensive. I don't think anyone would be interested or keen at this. And it was just at that credit crunch that we had, you know. And as I stopped, Chris Griffiths, who was then the CEO of Kumba, said, well, you haven't asked me yet. Yes, I saw this door just open, you know, because then I knew this is an opportunity. So I sent him a proposal, but you know, the proposal was basically a dream of what we want to do, and we gave him an estimate of the costs and so forth, because I just phoned the Aussies and said, listen, tell me how much and how far can we go with this. And I think it was about 6 months after that, the concept of budget approval was done. And I think a year later we got all the money, and it was an amount of 18.8 million rand to set up that facility. But then we found out we don't have a place to put it. That's really living your dream, you know. Anyway, so the university came to the party and they said, but wait a minute, let's put it on the roof of one of our current mineral sciences buildings. And then the dean had a vision of, but why don't we take the whole floor then and make it a new mining department? And true as hell. What then happened was, over a period of 3 years now, I think 4 years, where we started the planning of the whole floor, the whole new mining department, new research institute, everything, to form part of this virtual reality center. And what was so nice, what's his name, Chris Griffiths, when he gave us the money, he said, I don't want a movie house. It must be a design center where we could improve surface mines at that point in time to be more productive, more optimized, more safe, more healthier. How can we use virtual reality? So what we then did subsequent to that, we started looking at what are other people doing about optimization and about safety and all of that. And we came to the point where we realized that if we have the design tools, you know, whether it's a scheduler or an optimizer or whatever, if you could integrate all of that into a visual environment and then turn that into an immersive environment, can you imagine the power of how the effect that you could get from that? So what we then did, we designed a complete new laboratory for mining, a mine design laboratory. We then did what we call the 3D stereoscopic theater, like a typical cinema with the 3D glasses on. And then the third component was then, if you were doing this overview of the mine, and you then wanted to go into the stope or into the development, you would then go out of that into this immersive environment where you could physically move into the rock and see the jewelry coming towards you in the rock type of environment, and sort of do a lot of strata control issues and all of those things. So what was nice about the idea then was mining companies would be in a position now, and we've actually just set up a virtual reality mine design team, where they could actually bring their data, their log data, their borehole data, whatever they make, even from scratch, you know. Give it to us, we put it in a program, and we visualize whatever we have, and then we bring in the design team, and they would then convert the design into a visual environment. And if you really wanted to go to the nitty-gritty of in the face, you could go into the immersive environment. And at first we thought it was not going to be possible, or it would be quite difficult. And I think it's still a challenge, and that's why Australia has done a lot of good work on surface mines, but the underground mines have not been exploited as much, I think. So what we're doing now is we're getting people on board now. Several companies have approached us that wanted to go ahead now by visualizing, optimizing tools. You know, so you have almost a split screen environment where on the right hand side, and I'm talking about the theatre complex now, you have all your input data, and on the left hand side you've got your visualization where you can actually see how your data actually influences the run of the mine. And I think that's sort of the real reason why we wanted to go ahead with this, so that you could see the consequence of poor designs. Immediately shows you, because it's linked to mathematics. It's linked to the intelligence component of a design. You know, so it's not just a visualization anymore. It's really the mathematics behind that sort of triggers the visuals. And I think that's where we want to go with all of this. And this is now for rock engineering, vent engineering. You know, all the issues that we always had battles and problems with. I think we're at a point now where we will be able to start doing a lot of good work, I think, where people would benefit, not just from a safety and health, but from a cost perspective, from a return on investment perspective. You know, I just think, you know, to see your mine crash in video or in a simulation is better than to see it crash in 20 years' time, you know. And I think that was sort of where we're going with all of this. And like I said, our official launch is on the 4th of August. We've invited the Minister now, Advocate Ramatlodi, because we said this is unique. It's the first in Africa, and what we also have, it's unique in the context that it can be actually used by all countries north in Africa and make use of that facility. But like I said, we just touched the tip of the iceberg.
And how user-friendly is it for people to interact with?
What we've also said is the success would be, which you must remember, we're going to have an education component and a training component. And then with that is education in mine design, training in mine design. There's education and hazard awareness, there's training and hazard awareness. So there's a training and an education component. Now, because it's never been done on such a large scale, we're now learning as we go along. But what we've already decided is that what we're going to do is we're going to take, for instance, a tablet environment. You can only put 15 people in that immersive environment. So you take tablets, you give every student a tablet, and let's say you're busy with the hazard awareness program, the lecturer or the person in charge of the training, he could simulate a certain scenario, and the students must answer on the tablets. And the nice thing about it, you can then have a consequence of whatever they have cumulatively done wrong. Or you can do it in a way where the person that's really not knowing what's going on, that you can show what your consequence would have been if you had that design. So in terms of your question, we're not quite sure how easy or how difficult this interface will be. But Australians have already started doing it. They've been using it for quite a while in their education for mining subjects. So what we've got now with UNSW is we know the group of people there quite well, and we've got this arrangement now. They're coming to us in Australia and South Africa in July, and we will share programs. So we will develop new ones and share it with them, and they'll develop new ones, or we'll use theirs. And I think that's going to make it quite a nice project, because we don't have to redesign the wheel in terms of what they've done. And I think we've got some very good ideas which I think they haven't done, which I think we've already implemented now from our perspective. So yeah, it's exciting times. And yes, I think it's one of those innovations that when we really put it on the table 4 years ago, I didn't at that point in time realize the impact that it potentially could have in terms of safety and health. And for me, to be part of that, oh my goodness, it's exciting, it's innovative, and it's really something that people could look up to eventually.
And as a professor, how does that change the way you approach your job?
Very much so, in the sense that mining is one of the most difficult disciplines to actually visualize. If you talk to a student about a stope and a raise and a winds and a they don't have an idea what you're talking about. Now we have the facility that instead of taking him on the ground on a mine, we do the lecture, and the next period we take him into the immersive environment. So, okay, this is what the mine looks like. But it will never replace hands-on mining visits and going underground and really get the feel for it. But at least, you know, in doing that in a 3D environment, you could tilt that thing as much as you want, and you can show them where they would be walking and stuff like that. So from an education perspective, it enhances our ability to make very technical and very difficult scenarios very visual. And that's what we are so excited. You know, to answer your question further, we've actually gone further now that in our second year, we're now introducing a subject for our mining students, which we call virtual reality applications in the mining industry, which means that we've now designed a surface mine, an underground coal mine, hard rock mine, platinum, gold, and even a massive mine, you know, the basics of it. So that you take them in there and say, now you come from outside, you zoom into the mine, and then you go into the tunnels, and they can physically see what this mine looks like, you know. And so that's already almost done, and that we will be introducing in the second semester with our students. Do you know who's more excited about this? Our students. They cannot wait for this, go sit in a theater and see a mine, you know. And what we said I said to my staff, just make sure that they still understand the reality of mining. Mining is not this nice visuals and everything, you know, it's tough out there. But I think the fact that we're in a position where we could educate them better, I think that's the nice part about it.
Are these sort of things making mining more attractive?
I'm almost convinced that it will. And then you're sitting with the challenge that you still have to get the right people to do the mining. Otherwise, you know, because I'll tell you now, we from a mining or a mining discipline perspective, we get so many applications. You know, Wits University and ourselves are of the biggest English-speaking mining schools in the world now. I mean, I've got 400 plus students, Wits has got 700 plus students. We received 1,018 applicants for mining engineering last year for this year, of which 150 were approved because they qualified, and I think only 70 then arrived eventually. And I think the similar numbers is applicable to Wits. So it's literally a 10% success figure in terms of who applies and who then gets selected. And then I think our attrition at this stage, you know, the number of people that we keep is around about 60%. You know, so from that perspective, we don't lose as many as we had in the past. And I'm convinced that from making mining more sexy. You know, mining is not a sexy career. You know. And the fact that we get so many applicants, I think is sometimes for the wrong reason. It's for money, it's job security in a big way, because mining is going to be in South Africa for a long time. We're not going to get rid of mining in South Africa, not in you and my lifetime. So there's a keen interest in it, and the fact that we want to try and convert this harsh mining sort of vision into a more technical environment where you could design in a visual environment and do a lot of these. And the reason why I'm saying that is the kids of today, they love their iPads, they love their tablets, they love their cell phones, and I mean, they're in touch with the world, you know. And if we could get that excitement from a mining perspective also going with them, I mean, can you just imagine where we can go with this?
And in terms of your intake, is there a nice cross-section demographic?
Oh yeah, I think I'm very excited about this one as well. You know, University of Pretoria, when I became head of department in 2007, I think we were just over 200 students, of which half white, half black. We're now 80%, 78% black students, white students 22% obviously, and we've got 29% ladies in the mining department that pursue mining now as a career. And it had a lot to do with the mining charter, you know, had to readdress the imbalances and stuff like that, and I'm fully for that. We made a very good strategic decision in 2000 that we changed our mining discipline on Takkies to English only. So, and that immediately opened the door to African students, people from South Africa, black students specifically, and at this stage about 10% of my students are from Africa. You know, from the Malis and the DRCs of the world, you know, Zimbabwe and Botswana, which is actually quite nice because you have that international mix. And a lot of students from Namibia as well, you know, and that would not have happened if we were still Afrikaans. It would never have happened. From an historical perspective, if you look at the mining industry now, we've got Confuconia, we've got Chris Griffiths, we've got big names that it's been coming through the system, but in the last 10 years, what I'm so excited about is that our top 10 in the classroom has now become a split between black and white students. So it's no more a race thing, you know, it's a quality of education that has been maintained, and we're in a position now that, like for instance, our top student from last year, he's a cum laude student. He's a student from Namibia, you know, and for me, you know, that was, wow, you know, this is one of those, guy gets him from Africa and you make him the top South African student in the university context. Tony Kakana, for instance, one of my postgraduate students, he's been in Impala now. He's finished his honours degree in mining, you know. So those are the type of success stories that we currently have. We've got a French-speaking student, Jean-Paul, you know, that is Kayamba, you know. Top student, top 3 in the class, you know, comes from Mali, you know. And that to me is the success stories, that it's not just South African students that's been excelling in our department, it's also students from Africa. But if I look at the, from an Anglo-American perspective, from Sibanye, from Goldfields, the quality of the graduates that they also sort of get bursaries for, and then, you know, we educate them and then they go back to the mines. I think that's what makes my job so nice, is to see that you're actually educating the next generation of mining engineers. And having the virtual reality will enhance that even to the next extent, I think, because it's something that they're acquainted with. I mean, they live with it every day. And like I said to you, the most exciting portion of what we busy is the students. They are so excited about going ahead with this whole thing.
And what might the mine of 2035 look like from an engineering perspective with all these developments?
I think, to answer your question, at Wits University they're busy with a project what they call Digital Mine, which relates to real-time monitoring using digital technology in the underground environment, so as to optimize your whole approach to your mining cycle. Now, what I think what's going to happen now is that digital mine and also the virtual mine and all of those are eventually going to go into a marriage where you would literally have your whole mine virtual and digitally linked, so that you could actually on a real-time basis make changes and sort of, I think we're going to go way past this 5-year plan and 2-year plan. I think we're going to go 30-day plans, you know, and things like that, because the technology and the whole approach to design will be so dynamic that you'll be able to change it immediately. But you would be in a planning position before to visualize the consequences, so that you could be in a position where you are quite sure about what you're busy doing, because you've actually implied the whole mathematics behind your visualization.
And with deep mining, how do you get those visuals way 2K down, you know, to be able to project your virtual reality?
You see, that's the nice thing about virtual, is when we started talking to Anglo-American about what they've done, there's a guy at Anglo, Dave Drinkwater, that he was very much involved in implementing the whole virtual reality approach to planning in Anglo-American. That was sort of parallel to the time that we got the money and the facility that we would like to have. When I spoke to Dave about, when was it, about a month ago when he was visiting us, we were talking about, you know, when you go deeper and deeper and the technology is more and more available to look at what your geology looks like, you know, what are the, and everything that you need to actually enhance your mine design, because of so much information available. Now in the past, you had all this information, you didn't know what to do with it. Now you have all the information, you can put it in a program and you can visualize whatever you want to do. And then the other
so that's the good thing, you don't actually have to have a camera there to make it happen.
Exactly. And then the other thing, what's happened, scanning technology is now really world class. I mean, they fly a drone over an open pit mine in a week type of environment, a week or 2 weeks, and they would visualize that whole pit, you know, in terms of 1 millimeter accuracy, you know. And if you think about that, can you now imagine you've got this drone that could fly over that mine every month? How it will pick up all changes with regard to slope stability, failure potential, all of those things you could pick up, and you could build that into your programs. Where in the past, you know, to have measured that would have taken you a few days just to get one part of the pit sort of plotted out. But now you have that. You know, when I spoke to the scanning guys, they said to me, don't you want to use a drone to fly through your new building and show the world what it looks like? I said, how long will it take? 3 hours? And then we've got your whole department on And you can imagine, I said, when do you do it?
Yeah.
So I think if we're in a position where we could integrate all the latest technologies, because I think that's the challenge. And I think the nice thing about it is that the university is now involved with us. And we've put together now a design team to look at the future of this, because we believe that innovation should start with universities. If universities are not doing it, who the hell are going to do it? You know? So from our perspective, we don't know all the answers, but I think we've got enough resources available, you know, to experiment and to put new things on the table and to get things going in a big way. But I think from my perspective, I've seen it that the minute you give this young generation this visual challenge, you know, how to convert this information into something tangible, meaning seen, they love it. And they really want to make mining a more sexier environment. And I fully support them on that, because like I said, you know, taking mining 100 years in South Africa, we have a bit of an issue of making it sexy. I mean, if you just look at the people that are against mining in South Africa, yes, there's a lot of people that did wrong things, but there's a lot of good things as well. And unfortunately, the newspapers only focus on the bad things. And then I think Mark Tifani said, we either grow it or we mine it in South Africa. You know? And we must live by that credo that if we don't have mining, we have absolutely a disastrous economy waiting for us. And I think this Mining Indaba proves that, you know, that there's so much interest now just with the energy thing now. How will this lack of electricity, how will that influence mining output and production and so forth? And I think universities, there's another opportunity now, you know, to see how can we be involved in a strategy where this blackouts or this load shedding shouldn't be such an issue if it's done in a real structured way.